Okay, so we have here another example for relative motion. So you have here a plane, or plane A, as shown in the figure, is flying along a straight line path, whereas plane B is flying along a circular path having a radius of curvature of rho B equal to 400 kilometers. Determine the velocity and acceleration of B measured by pilot A. Okay, so what is being observed here is your plane B, and the observer here is your plane A. Okay, so let's first examine your figure before we go to our solution. Okay, so to examine your one, let's start with plane A. Okay, so plane A is moving on this particular direction, having a rate of, or having a velocity of 700 kilometers per hour. Okay, and it is accelerating at a rate of 50 kilometers per hour square, or square hours. So that would be the information that we have for plane A. For plane B, so it is moving on a circular path. Now, at this particular instant, your velocity, or the rate of your plane, is 600 kilometers per hour. Okay, the radius of curvature is 400, and then you have an acceleration which is pointed on this particular direction, having a rate of 100 kilometers per square hours. Now this direction here signifies that your plane B is decelerating. And then, by the way, since it is on a circular motion, and then you have here VB to be 600, that particular variable here, VB, is what you call your tangential velocity. Okay, so with that, let's proceed to our solution. So again, we are observing plane B. Your observer is plane A. So again, vector or velocity of the object being observed, and then the observer. Okay, so that would be equivalent to velocity of plane B minus velocity of plane A. Again, these are in vector form. Okay, now, if you were to have again the vector form for this two, you would have here, at this particular instant, we're analyzing again this particular instant. Let me emphasize on that one. Now, at this instant, your velocity for plane A is pointed on that direction and that alone. There would be no x component. Okay, same is true for this one. At this instant, it is only pointed on this direction, and this direction alone. There will be no x components. Okay, so if you were to write down your vectors for velocity B minus, or velocity B and velocity A, you would have that one to be velocity B relative to A now is equivalent to, let's start with this one. Again, B is 600, y component only. So writing that down, you would have here 0i, no x component, plus basically because it is pointed along the positive y-axis, plus you would have here 600j. Okay, again, this one is your VB. Okay, next, minus. You would have here naman is the vector form for this one. Again, no x component, 0. And then plus, again plus because it is pointed on that direction, 700j. Okay, so therefore, as simple as that, you combine like terms, 0 minus 0 is 0. You would have 600 minus 700. Then therefore, you would have here velocity B relative to A is equal to negative, what? 100J. Okay? And then take the absolute value, of course. Common sense will tell you, without doing Pythagorean theorem, you would have VBA would be equal to 100 kilometers per hour. Okay, now what does this negative sign means? Okay, that simply means that the relative velocity of B relative to A would be pointed along the negative y axis, as simple as that. Okay, pointed along the negative axis. If we were to analyze the vector for this one, you would have here, let's have here colors. Let's say that this one is the velocity of plane A, and then you would have here velocity of plane B. Okay, then therefore let's VB. Okay, then therefore your relative velocity of plane B relative to A would be this one. Again, connecting the tip and the tip, minuend and then subtrahend. Basically, that is your VB relative to A. Okay, so it is negative basically because it is pointed downwards. Okay, next we go to acceleration. Now for acceleration, okay, you would have here acceleration of B relative to A is equal to, you would have here your acceleration of B less the acceleration of A. For acceleration of A, that is very simple. You would have there already your acceleration for A. So again, since it is pointed on that particular direction only, you have no x component, then that one would be your vector form. It would be 0i plus, basically because it is pointed in positive, plus 50j. Okay, so next you have here for velocity of A, I'm sorry, that should be velocity of A. What I talked about is velocity of A. Next, for velocity of B here, you would have here your y component for the acceleration. Okay, and then you also have the x component. What is the x component? The x component would be your normal acceleration, a n. Again, normal acceleration is calculated by what? The normal acceleration is calculated as the tangential velocity square divided by the radius of curvature of the movement. Okay? So in this particular case, the tangential velocity would be your 600 kilometers per hour rate. And then you have already given radius of curvature. Okay? So if we were to write this down, let's start with B. Let's start with calculating first for the normal acceleration. Okay, so normal acceleration, which is your x component for your vector later on, is equivalent to, you have the velocity 600 square divided by, you have your radius of curvature, that would be 400. Okay, so you would have here a normal acceleration which is equivalent to 900 kilometers per hour square. Okay, per square r. Okay, okay, moving forward. Next, have here AB relative to A. Okay, or acceleration of B relative to A. Acceleration of B, let's begin with that one. X component is an, pointed on the positive direction, so you would have here positive 900 I. Next, y component, you would have here your y component to be pointed on this direction, that is in negative direction, so you would have here negative, what is that? Is that 100? Yeah, it is 100 kilometers per hour, or that would be 100 j, since it is your y component. Again, let me emphasize, this one is your a b. Next, you have here acceleration for A. Again, you do not have any x component, so you would have here 0i, and then next, you only have that one as the direction of your acceleration, so you would have plus 50j. Okay? Next, you simply combine like terms. Combining like terms, I and I combine, j and j combines. You would have here acceleration of B relative to A is equal to, you would have 900I minus 150J. Okay, that is the vector form of your resultant. Now, for you to calculate for the magnitude, you simply get the absolute value of the acceleration of B relative to A. That would be the square root of, you would have 900 square plus 150 square. Okay, which will give you absolute value of B relative to A now is equivalent to 912.414 kilometers per square hours. Okay, next is the direction. Let's denote the direction as theta. Same principle, ano? You have here arctan of, you would have negative 150. Let's just write there 150. You would have here 150 over, you have 900. Okay, or that should be, let's place the negative there, negative 150 over 900. So you will be getting theta now to be equal to, you have 9.4623. Okay, now having a graphical solution for this one is makes it a lot more easier. You would have here again emphasizing, you would have the length of the sides of triangle represents the magnitude of the acceleration. So you would have here, let's first have your acceleration for A pointed on that direction. You would have your acceleration for A, which is equal to 50 kilometers per square hours. Next is your AN. Now, since you have here your components, AN, and you have your tangential and normal acceleration, you can calculate for the resultant acceleration. Let's denote that one as AT. Okay? Now, for that particular acceleration, you would have what? You make use of your Pythagorean theorem again. You would have here A total is equal to the square root of 900 square plus 100 square. That would give you a total, sorry for the notation, total acceleration AT. Okay, so basically you would have here total acceleration. Since that one is for B, let's just change the denotation for that one, AB total. So you would have here AB total now is equal to, you would have there 100 or 905.5385. Okay? Okay. Now as for the direction, let's denote this one as phi. Okay? Phi is equivalent to arctan of, you would have the opposite, that would be 50, and then the adjacent would be 900. So you will be getting theta to be equal to, what is theta? That is 6.3401. So going back to your graphical solution, okay, so you have already have your established here acceleration for A. Next, for that one, you would have here, what is this one? You would have negative. Okay, so again, the length is the magnitude. That one is your theta with respect, or phi rather, phi with respect to the horizontal. That is 63.3401. Okay, let's just extend this a little bit longer. Anyway, we do not lack space. Anyhow, okay, going back. So you would have now your acceleration total, ABT, is equal to 905.5385, okay, kilometers per square hours. As for that one, you have there 50. Now, since we are observing plane B, okay, this is again acceleration of B, acceleration of A. So since you're exploring, or we are observing B, then your vector or your resultant would be, or the difference of vector would be this particular arrow. Okay, so you would have here A, B relative to A, or acceleration of B relative to A. Okay, now since that one is the case, you have here a side and another side, then you can calculate for this one because this one is 90 degrees. Okay, so you can calculate for AB. So you would have here acceleration of B relative to A, again making use of cosine law. You would have here 50 square plus 905.5385 square, and then minus twice the product, 50 times 905.5385 cosine of the included angle. So basically that is 90 degrees plus 6 point. Sorry, that should be 6 point, not 30, 63. You would have here 96.3401. Again, don't forget to extract the square root. Okay, so acceleration of B relative to A now is equal to 100 or 912.4142. Okay, now as for the direction, again with respect to the horizontal, let's denote that particular direction as beta. Okay, and then how do you get beta? If you know this angle, basically beta would be 90 minus this angle. Now for that angle, let's denote this one as angle alpha. Okay, again for sine law, you would have here 905.5385 over the sine of alpha, and then that would be equivalent to 912.4142 all over the sine of the opposite angle, that would be 96.3401. Okay, so therefore with this particular expression here, you can calculate for alpha. Alpha is equal to, you have 80.5378. So calculating for alpha now, I'm so sorry, that should be, yeah, it's alpha. Calculating for beta now, that would be equal to 90 degrees minus, you would have 80.5378. Okay, so with that, you have your direction of your acceleration now to be equivalent to what? 9.4623 degrees. Okay, so that ends my presentation, or that ends the video clip. Again, if you have any questions, just write it down in the comment box. So I hope you understand. See you mga Auranians sa susunod na ating lecture. Okay, so by the way, PS, your lectures or your activities will be posted at the classroom. Thank you.